Hey everyone, welcome. You know, we live in a world that's just swimming in ideas. So the real trick isn't coming up with them anymore. It's figuring out which ones are actually the winners. So, how do you separate the game changers from the ideas that are just dead ends?
Right? It's the million-dollar question. An idea can feel brilliant, totally revolutionary, but how can you really be sure? Well, that is exactly what we're going to break down today, and we're going to use some fascinating research that gets right to the heart of this exact problem. You know, every single organization, I don't care if you're a tiny startup or a global giant, lives with this constant tension. Over here, you've got the wild new idea. This is the big one, the breakthrough that could change everything. But it could also just crash and burn. And over here, you've got the sure thing. It's safe, it's reliable, but the reward? It's pretty small. Getting that balance right is pretty much the secret sauce of innovation.
And this whole conflict, it actually has a name you've probably heard, the innovator's dilemma. It's that classic struggle between being new and exciting versus being practical and possible. And as we're about to see, this old challenge has a very, very modern twist.
Just think about it for a second. With AI, we can spit out hundreds, even thousands of concepts in minutes. The bottleneck isn't generating ideas anymore, it's evaluating them. The most valuable skill in the room now is the very human one of looking at a mountain of possibilities and finding that one diamond in the rough.
Okay, so how do we get better at this critical skill of picking the right idea? Let's bring this down to Earth. Or actually, let's go to space. We're going to dive into a super cool field experiment from a Harvard research paper, NASA's Robot Challenge.
So the setup was the AstroBee Robotic Arm Challenge. NASA needed a new arm for its little free-flying robot up on the International Space Station, and the stakes, they could not have been higher. Any new design had to be genuinely innovative, but it also had to work, like, perfectly in the totally unforgiving environment of space. In the end, researchers had 101 different designs to sort through.
And to judge these solutions, they didn't just grab a few people. No, they recruited a massive group of 354 expert evaluators from all over the world to figure out which of these ideas really had the right stuff. And this, my friends, is where the story gets really, really good.
Because what the researchers found, almost right away, was that not all experts are the same, not even close. Their analysis showed that these 354 people actually fell into three very distinct and very important categories.
First up, you've got the domain-specific expert. This is your specialist. This person knows robotics inside and out, or they're an absolute guru in aerospace. Their knowledge is super deep, but also super narrow, and they basically act as the technical gatekeeper for their one field. Then you've got the domain-adjacent expert. Now, this person is smart. Maybe they're an electrical engineer or a material scientist, but they're not a specialist in either robotics or aerospace. And that little bit of distance makes them much more open-minded to weird, outside-the-box ideas, even if they're a little less strict on the technical details. And finally, we have the unicorn, the domain-spanning expert. This is the person who builds the bridges. They have deep, real expertise in both of the core fields. They get the robotics, and they get the insane constraints of putting that robot in space.
Now here's the kicker. These three types of experts don't just have different resumes, they actually have fundamentally different ways of thinking. The researchers basically uncovered this hidden mental process that everyone uses, but that each of these groups navigates in a totally unique way.
Turns out, it's a two-stage process. First comes what they call feasibility filtering. This is a gut check. The expert's brain is asking one simple thing. Is this even possible? If an idea doesn't pass that basic screen, boom, it's out. But if it passes, it moves to stage 2, integrative assessment. And now the question changes to, okay, it's possible, but does this new, novel thing actually make it better?
And this chart shows that process perfectly. Look on the left. When the evaluators' comments were all about feasibility filtering, the solutions they were looking at had, on average, really low feasibility scores. But then look on the right. When they switched into integrative assessment mode, the solutions were way more feasible. So it's clear, they filter out the impossible stuff first, then they go looking for the genius in what's left.
So check this out. This is how the different experts handle that first stage, the filtering. See that orange line? Those are the domain-adjacent experts. They're the most lenient. They let a lot of ideas slide through that feasibility check. But then look at the purple line, the domain-spanning experts. They are the toughest critics by far, constantly applying that feasibility filter, even on ideas that seem pretty solid. Okay, but now look at stage 2, because this is where the magic happens.
Once an idea is considered feasible, so we're looking at the right side of these graphs, that purple line for the domain-spanning expert just skyrockets. They are uniquely good at that second job, integrative assessment. They're the ones who can see how a cool new feature in robotics connects perfectly to a weird constraint in aerospace to create a true breakthrough that everyone else just misses.
All right, let's make this real. Let's look at an actual wild idea that was submitted. A robotic arm inspired by origami, driven by fluid and vacuum pressure. I mean, how cool is that?
So, the domain-adjacent expert saw this and was totally fascinated. They're focused on the novelty, Fluid-driven origami-inspired artificial muscles. They're thinking about the possibilities, the flexibility. Their mind is open.
But the domain-specific expert? Whoa. They slammed on the brakes, hard. Their feasibility filter just went into overdrive. They immediately said, I highly doubt the feasibility. For them, the novelty didn't even matter, because it couldn't get past that first big hurdle in their mind.
And then, here comes the domain-spanning expert, and they see both sides. They acknowledge the coolness of it. Yep, inflatable robots are a novelty. But then, they apply that incredible integrated knowledge to show you exactly why it won't work. They didn't just say no. They pinpointed specific cross-domain flaws, like underestimating the power needs and questioning if the grip force would work in space. That is a completely different level of thinking.
So what on earth does all this mean for the rest of us, who are not designing robots for NASA? Well, it means we need to stop looking for one perfect person to judge our ideas and start thinking about building a complete idea engine.
And honestly, this is more important now than ever before. Other research from Harvard shows that while AI is great at pumping out ideas, it tends to make them all kind of similar. The truly diverse, out-of-left-field ideas, those still come from people. So protecting our human creativity and getting way better at evaluating it is the real competitive advantage today.
So here's the playbook. You need a strategic mix of all three types of experts. You can even use them in order. Let your domain-specific experts act as the first-pass filter to weed out what's truly impossible. But then, you bring in your rare, precious domain-spanning experts to find the hidden genius in what's left. And you always want some of those open-minded domain-adjacent folks around to make sure you're not killing a wild idea too soon.
And all of this brings us to our final and maybe our most powerful takeaway about where we, as humans, fit into this new world of innovation. Look, when you bring these different expert mindsets into a room together, they are going to disagree, for sure. The specialist is going to focus on risk, the outsider is going to focus on novelty, and the bridge builder is going to focus on how it all fits together. And that disagreement? It's not a bug. It's the feature. That's the whole point. In an age of AI, maybe the most valuable human skill your team can have is learning how to disagree with each other productively to find that one truly winning idea. Thanks so much for joining me.